So this discussion around AI has been pretty impactful. I'm extremely encouraged that we're having the discussion because we absolutely need to. Everybody else is talking about it. Data scientists really need to be talking about it. So today we'll be talking a little bit about this fusion of artificial intelligence and digital transformation. And these two things, they sound maybe like they go together, maybe they don't. Certainly we need to clarify what we mean by digital transformation because it's kind of the new buzzword in addition to AI, and we'll do that. And then I'm going to share with you some real use cases about where Intel is actually making a difference in transforming other people's businesses. Now, you probably know Intel as the world-class silicon architecture manufacturer. We make, very large processing chips and silicon architectures around FPGAs and SSDs and NICs and all these things. But what you might not know is in the last 24 months, Intel spent over $1.5 billion buying 27 companies focused on the development of artificial intelligence. So the portfolio is large and it's expanding. And I'll show you all of the pieces associated with Intel's new AI portfolio, as well as how we're using that portfolio to drive real transformation and change. Now, why is it so important to have this discussion? Here's the reason. The primary reason is because today, more data equals more work. The more data you have, the more work you have to do to clean it, tag it, classify it, label it, provide metadata and provenance for it, and then you might be able to do some analytics on it. And we are approaching petabytes of data being generated by every single man, woman, and child on the planet on a daily basis. And if we as data scientists don't figure out a mechanism for creating a situation where more data doesn't equal more work, we will never realize the benefits associated with AI or digital transformation. Now, digital transformation, what is it? So there's a discussion around it here. This is ability to take advanced technologies, enable them so that we can transform businesses and organizations to fully leverage all the opportunities with this mix of technologies. And it's a fairly important thing. About 93% of today's Fortune 100 customers, our customers, are focused on transforming their business. They're trying to figure out what is it going to take in order for them to be more competitive and more relevant. And Intel, with its myriad of partners, most significantly today, our partner WWT, we're making a material impact on the way people, especially corporations and governments, are changing. Now, if you think data science is changing, let me give you a statistic. I think the number is about every 16 months or so, data science morphs into something new. Now, that's significant. But if you think that's bad, just think about what that means to a business. If every 16 months, you're rethinking the business model. You're thinking about your customer personalization and rationalization models. You're thinking about your new way to deal with the competition. You're thinking about a new way to deal with ecosystem partners and supply chain every 16 months. This is definitely a very big challenge. And so, we're really focused on it. We're really focused on it a lot. And so what I'm going to try and do now is give you the easy 101 class in analytics so that we can start deconflicting some of the things we've been talking about. The first is this idea of core analytics. This is where we're talking about diagnostic, descriptive, predictive, and prescriptive analytics. What happened? Why did it happen? What's going to happen next? What should we do about it? Right? And this is where many of our conversations start. But very quickly we move from that to cognitive computing and machine learning, which in fact is not really core analytics, but more associated with this pattern matching that's associated with machine learning. And we can do it in a number of fashions. We can do supervised and unsupervised learning. We rely on the fact that there's this large and larger set of data that's available. And we use that to train our algorithms so that we can make predictions about the future. 85% of projects in this space, according to Gartner, are failing. That means 17 out of 20 projects are not meeting their desired outcomes. And there are a whole host of reasons associated with that. But it's primarily because people haven't thought specifically about a data strategy before they start talking about an AI or machine learning or cognitive computing strategy. And then quickly we go from there to talk about deep learning and convolutional neural networks. And these capabilities, they help us to use these neural networks to drive better, more precise evaluations and analytic capability using mostly image processing. We're featuring our compute neural network stick, a USB stick that contains 4 neural network algorithms on it so they can support edge analytics. And then finally, we talk about this thing called AI. And in fact, we don't have very many representative samples of AI. This ability to outsource human cognition to a thinking machine, which operates at internet speed. That is something we don't see very much of in real life, although we see a lot of it in the movies, right? So when I came over here this morning, the lady in my Uber said, "So what are you going to talk about?" And I said, "Well, I'm going to be talking about AI." And so she said, "Oh, AI. Yeah, I know about that. I watched The Terminator." I said, "Yeah, you do know about it." Because that's as much as we know about it too. We don't have a whole lot of representative samples of AI running around. And so it's important to deconflict these, mostly because the sophistication level of our customers is getting higher. And when we conflate these, it weakens our ability to actually help them appreciate why it's important to invest in it, or the limitations associated with using it, or why they should trust it in the first place. So my first recommendation would be to be more precise about what it is that we talk about when we talk about data science or artificial intelligence. Now, these represent the full portfolio of Intel solutions. And as a simple way to think about it, Intel starts with the CPU that you know, which is here, right? So all these really great AI foundation elements and deep learning accelerators. And we build on that with a whole host of foundations and libraries and toolkits. And we put these together with our partners like WWT to create end-to-end solutions which represent the digital transformation or the transformational outcome that our customers are looking for. So whether we're using a deep learning library, or whether we're using TensorFlow, or we're building algorithms using R, Python, or NumPy, we are driving change across the entire stack of AI products and capabilities. And it's these that are the things that our customers are expecting us to come up with in order to create real outcomes for them. Are you ready to see an example of what I mean? This is the interactive session. Are you? Okay, good. Let me just share with you the rationale, though, of why companies are really interested in it. And the primary reason is because, as I mentioned before, this evolution is happening at an accelerated pace, faster and faster. And if we don't find a way to figure out how to harness the power of our data or these technologies that support that transformation, businesses, organizations, universities cannot keep up. So Intel is transforming healthcare. One of the examples that we're going to show here today is a combination of our Optane memory capability, along with advanced deep learning algorithms, and a partnership with GE to create a whole new way of providing healthcare. So as you can see, the lesson learned from this particular use case is simple. AI solutions and real outcomes do not come from a singular type of data science. This represents the fusion of multiple types of data science, the convergence of hardware, software, optimized for the hardware, as well as deep learning algorithms that allow us to create an entire new solution. This is tip one in transforming businesses and developing digital transformation. Now, there are some significant challenges associated with digital transformation. And the three that I'm going to highlight today are this lack of visionary skills. Now, you might say, well, why don't people have the visionary skills that are required in order to do digital transformation? The primary reason is because of the acceleration and evolution of business at scale. They're so focused on the running of the business or running of the institution that they can't look up and see what's happening 5 months from now or a year from now. And so it's very difficult to accomplish digital transformation because they're focusing on running the business. Additionally, we talked about the speed of technical change. Every 16 months or so, there's a new evolution of this idea of AI and data science. And so this speed is causing people to have a difficult time actually realizing any of the goals. But there are some important benefits if you take the time to do it. If you take the time to do it, you will realize greater profitability and efficacy, improved customer satisfaction, and the ability to increase speed to market. Now, this is not necessarily a big deal for a university, but for a business, it's a very big deal. It is absolutely essential that organizations find a way to harness the power of their data so they can get to the marketplace. Are you ready for the next use case? Yes. Okay. Intel is changing the motion picture industry. We are changing the motion picture industry. Now, you probably didn't know that Intel had a motion picture division, but we do. And here's one of the first movies. Well, this isn't the first movie. I think Wonder Woman was the first movie. Here's an example of a movie that we did.
The challenges when you're creating digital characters on the feature film side is that we have to support the narrative for the film, and the filmmakers are constantly challenging what we need to create for them. So with something like the Meg in particular, we had an animal that everyone kind of understood what it looked like but had never really seen.
When working on creatures, the very important aspect, if not the most important aspect, is to create an underlying machinery that triggers all the different aspects of anatomy at the right time. It's a very complex relation between all of these different aspects, and that is where Ziva comes in play.
At Ziva, we help creators make amazing creatures with the power of Intel AI. So like if you look at like all the complex motion that you see on the gills, like all the wave propagation that you see, all that stuff is a product of running simulations using our software. The ways that we use Intel Xeon scalable processors is to generate amazing training data. So what that means is, with our characters that we create, we make them go through every conceivable pose that you could imagine that character to be able to produce. And that is what our training data is. And then that feeds into our AI algorithms to make these characters run in real time.
To do a movie like the Meg, we really need like a massive amount of performance in our computer systems. And many years ago, you might have been able to do 1 or 2 shots, but it would have taken a huge render farm and a large crew to do that, and you would have only had a trailer shot and not an actual movie. So today, really, the performance came together with our render farm, where we have almost 2,500 Intel Xeon-based processors with almost 100,000 cores that really can be used to compute all needs of a movie.
When an audience member walks away after watching Meg, I want them to feel like they were immersed in the story, that they believed the Meg was of our world, and that we sustain that belief, that immersion, and that they were with us every step of the way.
So, the reason Intel's transforming the movie business is because we're trying to appeal to a much wider audience of data scientists. There's no sense in developing data science capabilities and artificial intelligence capabilities in a narrow space when you have the breadth and depth of a company like ours. So people who like to build movies, who like to tell great stories, who just need the capabilities associated with deep learning, artificial intelligence, machine learning, advanced compute, these capabilities are now open to them. But what's the real lesson learned in this use case? The real lesson learned, tip 2, you can't do it by yourself. You are going to need an extended ecosystem of partners, people who have domain knowledge, people who have understanding of how these compute systems operate, the people who know how to write algorithmic software tuned to that hardware, people who know how to use that entire capability to tell a story that fully immerses you in the experience, that fully immerses you in the experience. We'll see much, much more of this when we talk a little bit more about AR and VR as we move forward through the spectrum. So we've talked a little bit about some of the use cases. Intel's engaged in a couple of more I'll just share with you. First, we talked about health and life science, and whether we're talking about the collaborative cancer cloud, whether we're talking about immunotherapy, whether we're talking about advanced precision medicine using genotypes and phenotypes for DNA and RNA repositioning, whether we're talking about synthetic biology, all of these health and life science offerings are being transformed, accelerated, and enabled by Intel. Additionally, we have this focus on, what is that, nice little robot? These robots are starting to look a lot more like humans, but the ones that we really ought to be paying attention to, and the ones I think you ought to be paying attention to, are the ones that are focused on precision manufacturing. They don't look anything like humans. Or as the one my wife's a chef, she is constantly concerned about, is the one that knows how to cook a meal from start to scratch without any human being involved. Lawyers that see robots that are able to do discovery and put together briefs. Electricians that know how to build a 3D home in an automated fashion. These are the kinds of automation capabilities that are being transformed by Intel and its partners. And of course, you saw some of the stuff we did at the Olympics. I think the drone light show is the one that most people remember, and we've shown this capability quite a few times, right? And we are now transforming this concept of whether you can program thousands and thousands of drones to create an immersive light show. And we have autonomous driving. If you come out to our track in Santa Clara, you'll see there's an autonomous driving track. We're working with almost every major automotive company in order to help them accelerate the move from human-assisted driving, which is kind of what we have now, to full autonomous driving. And then lastly, but not least, these drones. These drones, these light show drones, they represent a whole new way of being able to communicate messages at scale. You ready for the next use case? Yeah. Before we get there, I wanted to share with you this list of skills that the OECD, the World Economic Forum, listed as the most important skills for the future growth of the economy. And this was done in 2015. And predictably, you'll see some of the things you've seen on this list before. But now I'm going to show you the next version of that list, and I'm going to ask you what you notice about it. There's something that was not on there that is now on the list. Yes, sir? More people-oriented, yeah, so that's good. But there's another one. Emotional intelligence. Emotional intelligence is the number one skill to be taught to people in order for them to be successful in their careers. And if you haven't gotten anything out of this conference so far, almost every single AI presenter has said we need to have a more serious focus on ethics and human-centered design capabilities, keeping humans engaged in this discussion around AI. It means we have to get better. We, when I mean data scientists, we have to get better at emotional intelligence. We have to put it in our schools. We have to put it in data science training. We have to evaluate data science against their ability to communicate and how they are internalizing emotional intelligence. If we do not, now this list suggests that we're not going to be very successful. Okay. Intel Sports. Did you guys know Intel has a sports division? Of course you did. I'm going to show you a use case around how we are transforming sports.
How our fans are watching the game is completely different than what it was years ago. An average person is watching NFL content across 5 different devices. So that really makes us have to think about our role in how we deliver the game differently. Intel thinks big. So it's not about incremental moves forward in terms of how we advance this or think about the next year and onward. It's about where are we going to be in 5 years, in 10 years' time. About 2 years ago, we were introduced to the Intel team as some of the drone light shows were starting to become popular. So as we thought about how to push things farther this year, we developed a custom lantern drone show that allows the drones to operate indoor in a closed system. We started off a partnership with Intel around TrueView technology. For TrueView, we have 38 cameras that line the bowl of the stadium. Those 38 cameras are capturing content from every single angle, taking that back to a server room, and then recreating the image of every given play so that then any user can go and move that around as they want to. The NFL's focus on innovation is also what ties us to Intel. And we view Intel as that partner who can bring that innovation for us and put us to a place where it's 5, 10 years down the way, and who knows what the fans are doing, but we know that it's going to be something amazing.
So, what's the tagline? The tagline is, we know the future because we're building it. Did anybody watch the national championship game yesterday? So you saw an example of TrueView at that game. TrueView technology is being used by every major sports league in the US, as well as Serie A, Premier League, Bundesliga. Every major sports area is now using Intel technologies to transform the sports experience. And what's the number one lesson learned here? Don't think small, think big. Digital transformation requires strategic, not just tactical thinking. From a data science perspective, it means we have to develop what I talk about in my leadership book as ambidextrous leadership. At the very same time we're talking about figuring out how to do something tactically, we need to be able to think about how it might relate to and drive us to something strategically. So think big. Think 5 years from now. What is the next generation of data science going to be? Will it be quantum computing, neuromorphic computing? Will it be non-silicon period? Will it have a supervised, unsupervised learning model? What is the human augmentation capability that needs to go with it to accelerate its adoption? These are the lessons associated with this use case. So that's it. I do have, how much time do I have, Julie? Okay, so I have time for one more use case. Anybody interested? Yeah. Okay. Intel is transforming motorsports. Did anybody know Intel has a motorsports division? Intel is transforming motorsports. Here's how.
Exactly 70 years ago, the first road car was leaving our factory. So in the 70th anniversary, there was not a better year to start this collaboration because all the experience, all the technology, all the knowledge that Intel has as far as artificial intelligence is concerned will give the possibility again to look at the race from a different perspective, increasing the experience both for the driver but also for the fan.
AI techniques allow us to basically bring together many sources of data and visualize it or find an outcome that we wouldn't have seen before. We can use AI techniques to teach drivers to drive better. What that means is pointing out where they could do things differently and be faster, or actually intervene in sort of small amounts going around a track, for instance. We have in-car video. You can see what's happening within that car or in front of that car, but you can't really see the relationship with that car and the track, the relationship with that car and other cars. Now we're deploying drones, and we can start getting video feeds of all different corners of the track and syncing it up with data coming from the cars. 5 years from now in the motorsports world, I believe we're going to be using a lot better analytics based upon AI techniques. A human can only take so much data in, and that's really what AI systems can do. So we can bring together much more data with these systems, things we really couldn't do before.
Why Intel and Ferrari? I think the right question is, why not? And why we waited so long?
Right, so what's the message? What is the key learning from this use case? The key learning from this use case is obvious. What is it? Oh no, that's just a tagline. I love that you picked that up there. The use case teaches us to think outcomes. Do not think of data science as the end state. Data science is not the end state. Data science is simply an enabler. AI is an enabler to do something else. The question is, what is it going to do? We are the ones that are going to be figuring that out. Focusing on outcomes helps us drive priorities, helps us envision a future where we control AI for the betterment of civilization, whether it's in motorsports, in sports, in healthcare. You know, these are the things that are going to drive us. And so thinking about AI in terms of outcomes eliminates this kind of focus on technical things only and helps us to appreciate why we're doing what we're doing. And hopefully it would encourage us to think about the people who we are in fact doing it to. Okay, so that's the prepared comments. I think I have time for a couple of questions. Uh-oh. Oh, no. Okay, yes, sir.
Two quick questions. So, boy, there was a lot of stuff in competition and stuff like that, and I'm just wondering, so on the racing thing, you could basically have something in there that if there was going to be a crash or something like that, they were reaching a threshold of where they were in danger of a crash, that you could make an interaction, an intervention at that point. But then at what point on all of this competitive stuff, this is the first part of this first question, where's that line where you are now affecting the outcome of the event? So that's number one, and how do you...
Let's address that first.
Okay.
Because I think that's easy, right? We're not actually going to have an effect during the race as much as we will have an effect during the training associated with the driver.
Okay. Okay, because again, like let's say in a football game, if they're monitoring these things, they could effectively assess the speed of a defender on there.
So do you know what team was the first team to adopt TrueView? It's a Silicon Valley company. They have golden in their name, and they are one of the best basketball teams in the world.
Okay.
They predicted how important TrueView and analytics associated with each player, each individual play, how players react to other plays that are being run. That's no coincidence. This is about being able to take a deeper understanding of data and being able to understand it and apply it to a learning environment.
Right,
Okay.
and well, we talked about emotional intelligence before, and like during a basketball game, there's an emotional intelligence between those players, and in essence, AI could pick up on that and utilize that for the coach almost real time during the game. You know, but anyway, now my second part of my question, not as interesting, but quantum computing. Where does Intel sit with quantum computing, and what are we going to see from Intel and quantum computing in the next year? When will we see a milestone?
Yeah, so quantum computing is a big deal at Intel. We've already focused at Intel Labs around a $50 million investment in the Netherlands around ultra-pure silicon and the development of applying quantum physics in a super cooled environment, but not as cool as the negative 273 degrees that it currently operates in the Vesuvius chip in D-Wave now. We expect, however, that the maturation of the next generation of AI won't jump to quantum. we actually believe that the maturation cycle will begin in earnest in neuromorphic computing. And this is the ability to use biomimicry associated with brain research and apply it to silicon architectures so that we can learn in silicon the way the brain works in synapses. So we're taking an electrochemical model from the brain and applying it to neuromorphic computing. You'll see investments in the Princeton Neuroscience Institute as an example of how important it is for us to continue this discussion, as well as the new Lohihi, code Lohihi chip, which is our new neuromorphic chip. It has not been released, and it has only been available to certain customers for testing. But we absolutely believe that neuromorphic computing will be the next phase before we get to quantum. Quantum is still a set of solutions that's looking for the right question. You have one more question? Yes. Thank you for your questions.
So my question is, and you may not feasibly be able to answer this, how many different types of chips does Intel have? Is it like 500, 5,000? And when do you make that cut and say, we're going to change the architecture, this specific application or market needs a dedicated hardware architecture, and we don't just want to run it on the chips that we've already got going? Does that make sense?
Yeah, sure. So unfortunately, I can't give you the exact number of chips because there's a lot of them. But what you ought to think about is that as we continue to transform other people's businesses, there's areas that mean. So if you think about it from a data science perspective, we've seen a lot of stuff happening in the data center, right? Whether we're enterprise data center owned by another company, or whether it's a data center that's associated with a cloud deployment. So we have specialized silicon capabilities in both of those. We have this idea of edge analytics and edge compute. And so the trend is, of course, moving the compute to where the data is. When we think about just the advancement of 5G, it's going to have a material impact on our ability to have this synchronization between the edge and data centers. But we will, without question, as we grow to 50 billion new devices at the edge, be required to figure out how to use the chips at the edge to do inference and training. So that's one class. Then we have another class that's focused in on things like neuromorphic capabilities. Then we have another class that's focused in on discrete field programmable environments where we have, and this is particularly important for a data scientist because when we get trained, most of the time we're getting trained on developing of algorithms that operate in a very high-powered, high-performance environment. When we move them to an edge device, we need to rethink how we're doing algorithms in a low-power, low memory space. And so field programmable gate arrays offer application developers and data scientists an opportunity to take advantage of the in-memory capabilities of FPGAs as well as the flexible capabilities in the application area. So there's another class there. And you saw all of these wonderful use cases. Each one of them represents a class. We could go on. The next generation of our Xeon processor will be the ASIC chip, the application-specific integrated circuit. This is going to be significant because now we will have a silicon architecture that was specifically designed for deep learning applications. It will allow deep learning applications to run more effectively than anybody has ever made one run before. And we are focusing on doing code and workload optimization on x86 platforms so they run even more in a high-performance environment. So there's a lot of classes of capabilities, and we're focused on every single one of them. Good question. Thank you.
So that's just an incredible amount of scope that Intel is looking to absorb, become like a major player in multiple additional major industries. And I think you didn't even list them all.
I'm so happy you said that because that was the exact point of this whole thing.
And Intel has already made a bunch of acquisitions. How is there room for us to still have an industry full of companies with this level of ambition? Isn't everybody going to be running into stepping on everybody else? I mean, who is Intel going to have to merge with to realize this vision?
So I think that's a great question. I think just like every other company, Intel is becoming a data company. We are, in fact, undergoing our own digital transformation. We respect our competitors, but we think our strategy in data and data analytics is really, really important. And the reason it is because we're starting with a CPU that most people on the planet already have, either in cloud or in their devices, and we're able to extend that in ways that no other people can. And so, we think that if you were at our strategy session, what you would hear our senior executives say is, Intel is no longer the dominant player in the largest market in analytics or AI, because the market has grown. We were the 90% owner of that market, but the market we are now going after is 4 times that big. So we have some work to do. We're encouraged by it, though. Yeah, I think probably the other thing that's interesting is, on a personal note, I think it's important to think about. I've been with Intel 3 years. Prior to that, I was Vice President and Senior Fellow at Lockheed Martin, responsible for advanced research. The reason that that's significant is because it shows you that Intel is making a significant commitment about hiring people who now have a different skill set. We are no longer interested in hiring people who only know silicon architectures. We have to have people, and by the way, I think we have hundreds, don't quote me on this, check the website, of data science openings to fill these jobs around advanced silicon married with high performance algorithms and computing and data. So, we're extremely encouraged. We're getting some really great people. You probably noticed that in the news. And I think one of the things that we just launched was our second generation, parallel processor, the Cascade Lake, right? That was just released April 2nd. And so what you're seeing is a constant rollout of new products that have been born out of the acquisitions we're talking about. So when you think of a company like Data Robot, HQO AI, Element AI, these are all Intel investments that are now being applied to these problem sets that we've been talking about.
I'm curious about how Intel is approaching the ethical questions around AI. Google recently got under fire for their ethics panel, and Intel, at its scope and size, really has a lot of impact on the ethics. So, what are the concerns that you're addressing internally?
Yeah, so I appreciate you asking that question because I live in Washington, D.C. for this very reason. People say, why is the chief data scientist at Intel live in Washington, D.C. instead of Silicon Valley and Santa Clara? And it's because not only for this issue around ethics and privacy and the legislative agenda that's driving it, but because the largest steward of the largest data sets in the planet is in Washington, D.C., and the people who make the rules about how they are going to be used and governed is in Washington, D.C. So more specifically, to answer your question, we just released 3 documents that are really important. The current administration released its executive order around artificial intelligence about 3 months ago, and Intel published a response to that executive order indicating what we think the national AI strategy ought to be. And it's a publicly available document. You can go there and find it. The second document is a document specifically related to ethics and privacy. And we are a global company, right? 500 countries. So we are hypersensitive about how people view and use data. People have an expectation about how we're going to view and use it. So we're tracking the legislative agendas associated with the GDPR, the 26 states in the United States that now have new legislation around privacy and ethics, and every other country. And we've actually published our ethics documentation so that you can read what we're thinking. There are 4 or 5 major recommendations in that document that describe what we think are important first steps in dealing with privacy and ethics. And I would encourage each one of you to kind of download it and read it. And then I think the last thing that we published was a set of recommendations around why AI is important. The previous administration in 2016 created an R&D AI plan, which unfortunately is no longer available on the White House website, coincidentally. But we did publish a response to that document as well, which describes a set of recommendations around R&D research. specifically given the fact that industry is bearing more responsibility associated with R&D research than the government is, right? So when we take a look, we've got government with a decline in the amount of dollars that are going to advanced, basic, and applied research, and we have industry with this uptick. And so we listed a series of recommendations around that, focused on what to do around privacy. Because, of course, algorithmic warfare, this is a reality. Weaponization of data, that is a reality. And data scientists, just like you and I, are the people who are doing these things. And so, when we see these activities, then we want to be able to, as you say, use our voice to support ethical uses. And then lastly, I'll comment on, we've created a new organization inside Intel focused on AI for social good. And in this case, we're looking at a number of things, mostly the 17 United Nations Sustainable Development Goals, SDGs. These 17 are focused on things like hunger and water quality, education, and so on. And so we are organizing our AI capabilities to support these United Nations Sustainable Development Goals. So I hope I answered your question. Thank you very much.
And thank you to Melvin Greer.